This is Why You Dreamed. A deep dive into dreaming. Dreams have captivated human imagination since time immemorial, serving as a source of mystery, inspiration, and intrigue across cultures. Throughout history, they've also played a significant role in shaping beliefs, decision-making, and creative endeavors. In ancient Egypt, dreams were considered divine messages, with dream interpreters holding esteemed positions in the royal court. The Greeks and Romans believed dreams could foretell the future, with figures like Artemidorus writing extensive dream interpretation manuals. In many Native American cultures, dreams were seen as journeys of the soul, providing guidance and healing. The scientist Dmitry Mendeleev even claimed the structure of the periodic table came to him in a dream. While dreams have long been steeped in mysticism and spirituality, modern neuroscience is beginning to unravel their mysteries. And research is revealing that the border between our sleeping and waking selves is less strictly defined than we might think. Recent studies suggest that dreams play crucial roles in memory consolidation, emotional regulation, and problem solving. They may even serve as a form of nocturnal therapy, helping us process and integrate our daily experiences. If you've ever been curious about dreams, then join us as we explore the cutting-edge science behind this nightly dose of wonder. Electricity and evolution underpin our dreams. The neuroscience of dreaming is a fascinating field that continues to unlock the mysteries of our sleeping minds. Dreams originate from the electrical activity of the brain, just like all forms of consciousness. However, during sleep, this electrical activity is distributed differently across various brain regions, leading to unique experiences. One key difference is the increased activity in the limbic system while we dream. The limbic system, a set of brain structures involved in emotions, behavior, and long-term memory, sees a boost of up to 15% in activity during dreams, compared to only 3 to 4% during waking hours. This explains the intense emotional experiences we often have in our dreams. Scientists previously believed that dreaming only occurred during REM sleep, which typically occurs in 2-hour phases throughout the night. REM sleep is characterized by rapid eye movements, increased brain activity, and temporary muscle paralysis. But recent research suggests that dreaming can happen in any sleep stage. This new understanding implies that we might spend up to 1/3 of our lives dreaming, not just sleeping. Dreams are a form of stimulus-independent cognition, meaning they don't require external input to occur. This type of thinking is also present in daydreaming or mind-wandering during waking hours. In dreams, our brains create entire worlds and narratives without any sensory input from the external environment, showcasing the incredible power of our imagination. To enable dreaming, the brain's central executive network, which is responsible for goal-directed behavior and cognitive control, needs to shut off. This allows the default mode network, or DMN, to take over. The DMN, which could be more aptly named the imagination network in this context, is active when we're not focused on the external world. It seeks out loose associations, makes random connections, and asks what-if questions, weaving narratives out of seemingly thin air. Interestingly, despite the limitless possibilities of our imagination, dreams often fall into recognizable patterns across cultures. Common dreams include falling, being chased, being at school, or arriving late for something. These patterns might exist because dreams often focus on emotions and interpersonal relationships, acting as social experiments powered by the medial prefrontal cortex, or MPFC. The MPFC is crucial for social cognition, self-reflection, and decision-making in social contexts. Several theories have attempted to explain why we dream. Some researchers believe dreaming evolved as a form of threat rehearsal, preparing us for potential dangers in waking life. Others suggest dreams serve a therapeutic function, helping us process and metabolize daily emotions. Another theory proposes that dreaming keeps our minds alert and prepared during sleep. The overfitted brain concept, proposed by neuroscientist Eric Hole, offers another intriguing explanation. This theory suggests that dreams introduce noise into our cognitive systems, preventing our brains from becoming too specialized or overfitted to our daily experiences. This noise helps maintain our ability to generalize and adapt to new situations. In reality, there's likely no single explanation for why we dream, just as there's no single neuroscientific explanation for our waking behaviors. Dreams remain a complex and multifaceted phenomenon, reflecting the intricate workings of our remarkable brains. As research continues, we may uncover even more surprising insights into the purpose and mechanisms of our nightly adventures in the realm of dreams. Nightmares are necessary nightmares, those vivid and frightening dreams that jolt us awake, are a universal human experience that has long fascinated neuroscientists. While most of us view nightmares as unwelcome intrusions into our sleep, they may serve important functions in our cognitive development and emotional processing. It's crucial to distinguish between nightmares and bad dreams. While bad dreams may provoke unpleasant emotions or depict negative experiences, like waiting endlessly for a bus that never arrives, nightmares are characterized by their intensity and their ability to wake the dreamer. In regular dreams, we can often decode the motivations of other characters, but nightmares pitch us into battle against an inscrutable and terrifying other. Nightmares, like dreams, tend to follow common patterns across cultures. Widely reported nightmare themes include experiences of failure and helplessness, being attacked, health-related concerns, and accidents or impending death. These universal patterns suggest that nightmares might play a role in our evolutionary history or cognitive development. Interestingly, children are 5 times more likely than adults to experience nightmares. This higher frequency coincides with a period of rapid cognitive growth, leading researchers to hypothesize that nightmares may play a crucial role in childhood development. Children aren't born with the ability to dream, it's a skill their brain develops over time. Some scientists propose that dreams, and especially nightmares, help children learn to distinguish between waking and dreaming states, and to formulate their sense of self through scenarios where that self is threatened. Even in adulthood, nightmares typically feature the dream self under threat rather than some other entity. The lasting impact of nightmares on the brain was dramatically demonstrated in the 1950s by neurobiologist Wilder Penfield. In his groundbreaking awake brain surgery experiments for epilepsy patients, Penfield used an electric probe on the exposed temporal lobe. When applied to specific points, the probe triggered vivid recollections that patients described as more real than ordinary memories. Among these recollections were nightmares, suggesting that these frightening dreams leave a lasting imprint on our brains. But are nightmares useful or merely an evolutionary relic? The energy expended during nightmares, quickened breathing, increased heart rate, and intense emotions suggests they serve a purpose. What exactly is this purpose? Well, we don't yet know. But the brain typically conserves energy where possible, so the fact that it dedicates significant resources to nightmares implies they may have an important function. Fascinatingly, research indicates that nightmares might even have a genetic component. Studies have shown that nightmares tend to cluster among family members. A study of 3,500 pairs of twins in Finland revealed gene variants linked to nightmares, raising the intriguing possibility that we might be passing the scripts of our nightmares from one generation to the next. While nightmares can be distressing, they appear to be more than just unwanted side effects of sleep and dreaming. They may play crucial roles in our cognitive development, emotional processing, and perhaps even our evolutionary history. As neuroscience continues to unravel the mysteries of our sleeping brains, we may gain even deeper insights into the purpose and mechanisms of these intense nocturnal experiences. This could not only help those who suffer from frequent or severe nightmares, but also shed light on the broader functions of sleep and dreaming in human cognition and well-being. Dreams promote creativity. The relationship between creativity and dreaming has long fascinated scientists and artists alike. Dreams offer a unique window into the mind's creative potential, providing a playground for free, associative, and non-goal-oriented thinking, the very ingredients that fuel creativity. Our brains operate in 2 primary modes, the executive network and the imaginative network. During waking hours, when we're focused on tasks, the executive network keeps us on track. But when our minds are allowed to wander, say, while showering or folding laundry, the imaginative network takes over. This mind-wandering state is conducive to eureka moments, where we suddenly solve a problem or conceive a brilliant idea. In this mode, our brains are more likely to form unexpected connections, leading to novel and surprising thoughts. A study conducted by sleep researcher William DeMint at Stanford University in 1972 highlighted the problem-solving potential of dreams. DeMint asked 500 students to spend 15 minutes each night attempting to solve brain teasers before sleep, ensuring they dozed off with an unsolved problem in mind. The results were intriguing. Students reported 87 dreams, 7 of which provided solutions to the brain teasers. While solving riddles in our sleep is impressive, the real value of dreams lies in their capacity for divergent thinking, another term for the mind-wandering mode. This may explain why individuals in creative professions tend to have better dream recall than those in other fields. The rapid shifts in place, time, and character that characterize dreams have likely inspired countless creative works throughout history. One of the most famous examples of dream-inspired scientific breakthroughs comes from the field of chemistry. In the 19th century, chemists were puzzled by the structure of benzene. The solution came to Auguste Kekulé in a dream. He envisioned a snake made of atoms biting its own tail, leading him to realize that benzene's structure was a closed ring. This dream-induced insight illustrates two key features of problem-solving in dreams: the decreased activity in brain areas that usually restrict our thinking to the logical and familiar, and the heightened activity in visual areas that allows for vivid visualizations of potential solutions. Of course, creative ideas and flashes of inspiration need to be followed up with focused work. A recent BrainScan study of a poet writing and revising a poem showed a constant flashing between the imaginative and executive networks, highlighting the interplay between creative inspiration and disciplined execution. For those looking to harness the creative power of their dreams, research suggests that the sleep onset phase, the transition between wakefulness and sleep, is particularly fertile ground for creativity. A study conducted at MIT demonstrated that when people are prompted to dream about a specific topic during this phase, they perform much more creatively on related tasks upon waking. In this experiment, participants who received targeted dream incubation generated more creative stories than those who napped without a specific prompt or those who stayed awake. The researchers believe that during this dream state, the brain makes more wide-ranging connections between disparate concepts, providing a significant boost in creativity. This opens up exciting possibilities for intentionally using our dreams to enhance our creative abilities in our waking hours. The intersection of dreaming and creativity offers a rich area for exploration, both scientifically and personally. By understanding and harnessing the creative power of our dreams, we may be able to unlock new realms of innovation and artistic expression in our daily lives. Unlock the potential of lucid dreaming. Dreams offer a wealth of emotional, interpersonal, and creative benefits, but their ephemeral nature makes them difficult to study scientifically. The content of our dreams often slips away moments after waking, leaving us with only fragments of the rich narratives we experienced during sleep. This is where lucid dreaming comes in. This phenomenon offers a promising solution to this problem, even though our scientific understanding of it is still in its early stages. A groundbreaking experiment in the field of lucid dreaming research took place in 1975 at Hull University. Psychologist Keith Hearn used an electrooculogram, EOG, to record a pre-agreed set of eye movements signaled by an experienced lucid dreamer, Alan Worsley, while he was in REM sleep. This marked the first time one human being had communicated with another from inside a dream, opening up new possibilities for dream research. But what exactly is lucid dreaming? It's the experience of dreaming while being fully aware that you're in a dream state. Although thinkers from Aristotle onward had proposed the existence of lucid dreaming, science was slow to accept it until Hearn's experiment. Now, researchers have an expanded understanding of how lucid dreaming works. For instance, studies have shown higher rates of activity in the prefrontal cortex, the logical part of the brain, during lucid dreams. And interestingly, transcranial stimulation through electric pulses has been found to prompt lucid dreaming in some individuals. The potential applications of lucid dreaming are vast. Scientists and therapists have used it to alleviate recurrent nightmares and symptoms of PTSD, among other conditions. It offers a unique opportunity for individuals to confront and potentially resolve psychological issues within the safe confines of their dreams. If you're interested in trying lucid dreaming yourself, there are several techniques you can explore. Wake-initiated lucid dreaming, or WILD, is a technique that involves maintaining consciousness as you transition from wakefulness to sleep. Lie still with your eyes closed, relaxing your body while keeping your mind alert. As you start to experience hypnagogic imagery, hallucinations that happen as you're falling asleep, try to enter the dream state consciously. Then there's mnemonic induction of lucid dreams, or MILD. Before going to sleep, tell yourself that you'll remember you're dreaming. Set an intention to recognize when you're in a dream. Throughout the day, perform reality checks, like trying to push your hand through a solid object, to build the habit of questioning whether you're dreaming. Another tactic to practice lucid dreaming is keeping a dream journal. Write down your dreams immediately upon waking. This improves dream recall and helps you recognize dream signs that can trigger lucidity. Finally, try practicing meditation. Regular meditation can increase your self-awareness, making it easier to recognize when you're in a dream state. Remember, becoming proficient at lucid dreaming takes time and practice. Be patient with yourself as you explore this fascinating aspect of your mind. Final summary: the main takeaway of this summary to this is Why You Dream by Rahul Jandial is that dreams are complex neurological phenomena that serve various functions, including emotional processing, problem solving, and creativity. While nightmares may have evolutionary significance and potential genetic components, lucid dreaming offers a unique opportunity to consciously explore and potentially harness the power of dreams for personal growth and therapeutic purposes. Okay, that's it for this summary. We hope you enjoyed it. If you can, please take the time to subscribe. Want the full audiobook? Check the description below. Thanks for watching.